Hello everyone, data structures, algorithms, recursion. Today we'll talk about the recursion. Before we move on, you need to understand this topic. The factorial algorithm. A method is a recursive method when it calls itself. The factorials for negative numbers are undefined. The factorial, if you see it mathematically, it is this symbol n for any number, and then you just multiply n with n minus 1. Always then the 0 factorial and the 1 factorial give you the result of 1. For example, if you have the factorial of 3, then you have 3 multiplied by 3 minus 1 factorial. This means 3 multiplied by 2 factorial, because 3 minus 1, 2. And then you have 3 multiplied by 2 multiplied by 2 minus 1 factorial. And as you can see, we have already stated that the factorial of 1 equals 1. Then you have in the end 3 multiplied by 2 multiplied by 1, and you have the 6. So the factorial of 3 gives you a result of 6. You can do it with every other number. Let's calculate now the factorial for a number. We will use two different methods, one iterative method and one recursive method, and you will understand the difference also in the code. The iterative method. You can create a method that takes an integer n as a parameter. We will see it later on Eclipse. And you can say if the variable n is equal to 0, the factorial is 1. So we stop because we have a result, and then you return this result, which is 1. Otherwise, if n is not equal to 1, you set a factorial variable f, for example, or you can name it whatever you want, to 1. Then we set the multiplier will be the I, to 1. While the multiplier is not equal to n, for example, if you have taken the number 3, if you set the number 3 as a parameter, while the multiplier is not equal to 3, you could say in this step. Repeat steps 5 and 6, and let's see the steps 5 and 6 now. You multiply f by multiplier and assign the result to f. And we can write it in Java this way, as you can see here. And then you add 1 to multiplier. You add 1 to multiplier until you reach the number n. When you reach the number n, then you stop, because the result will be f. Are you a little bit confused now? You will see it written in Java in our next video with one or more smooth explanations, and you will be able to understand every single line of our previous slide. What about the recursive approach? The recursive approach happens in just 2 lines of code, and no loop is included. For example, we can write it this way. We will see it also in Eclipse how it works. Here you have a method and just 2 lines of code. You say if n equals 1, then you just return the 1. And then return n is the number inside the parameter, multiplied by the method. By the method and the parameter you give the n minus 1. So for example, if we have the number 3 as n, so we just set inside the parameter the number 3. Then it returns 3 multiplied, as you can see here, multiplied by my recursive method n minus 1. n minus 1 means 3 minus 1, and this is 2. So you have return 3 multiplied by my recursive method 2. What is the recursive method 2? You just do the same thing. You say if n equals 1, return 1. Is n equals 1? No. Then you go further and you return n multiplied by the method minus 1. By the method n minus 1. Excuse me. So you have 3 multiplied by 2 multiplied by my recursive method 1, because n minus 1 means 2 minus 1, and you have 1. And now you just run this method, the myR method 1. You can imagine it like a stack, and you will understand why. In myR method 1, you have n equals 1, so you just read the first line of the code. If n equals 1, you return 1. So you have return 3 multiplied by 2 multiplied by 1, which is 2 multiplied by 1 multiplied by 2 multiplied by 3 multiplied by 1, and you just return 6, which is also the result. Or you can think it like a stack, exactly what I told you. You return 3, let's say we have the same example here. So you have n equals 3. So you return with the first iteration, with the first recursive iteration, 3 multiplied by your method n minus 1, which is 2. So you just save this 3 in a stack. Then you run the f2 method. The f, I mean when I write f, I mean the my recursive method. Then you run the f2. The f2 gives you 2 multiplied by f1, because 2 minus 1, 1. So you just put these 2 in a stack. So you can imagine that these circles, the numbers inside the circles, are the stack. And then you just run the f1 method. The f1 method gives you as a result 1, and you just put it on the stack. So you have a stack which is now to be returned. And how do you return a stack? You just pop up the numbers. The first number to be popped up is the last number that you inserted in this stack, which is the 1. So pop up 1, then multiplied by the second one, which is the 2, and then multiplied by the third one, which is the 3. So you have 1 multiplied by 2 multiplied by 3, and your result is 6. So no matter what approach you take, in order to think and understand it, it's always the same method. If you ask me, the best way to remember it and to learn it is to understand it like a stack. A recursion is like we take a result, we save it to the stack, so it goes to the bottom line, and then you just repeat recursively this method, and then the next result you save it to the stack, and you continue on. And when you are ready, you just pop up the stack and you use all the saved results. What does recursion give to us? We have a clean code, but if you think about the speed, the algorithm speed, well, there you certainly have a problem, but there are always methods to solve such problems. We will see the implementation of this theory in our next video.